Hi everybody, it's Ms. Dupree. In our last lesson, we learned about ecosystems, what they're made of, how things interact in ecosystems, and how we organize them into different levels. But ecosystems cannot function unless they have energy. In today's lesson, we're going to look at how energy flows through ecosystems. So last night, I had a delicious cheeseburger at Smashburger in the mall, which is my favorite hamburger place. And I'm thankful that I had food to eat last night because that food gave me the energy to make this video. So my question is, what or who should I thank for that energy? Should I thank the cow that gave the meat and also gave milk for the cheese? Or should I thank the wheat that gave me bread? Or maybe the tomato and the lettuce plants? Well, no, actually, we need to thank the sun. Think about it. Where did the cow get its energy? Well, yeah, from the grass it ate. But where did the grass get its energy? From the sun. In fact, all of the food we eat can be traced back to where it all started, the sun. The sun provides energy to ecosystems. And once that energy from the sun enters the ecosystem, it moves from organism to organism through the ecosystem, passing energy along each time. We can trace the flow of energy through ecosystems by creating food chains. You've probably heard of food chains, but I need to make sure that you know how to draw food chains correctly and that you can classify all of the different types of organisms that make food chains. There is going to be a lot of vocabulary in this video, and you do need to make sure that you know all of it. Of course, our food chains are going to start with the sun. And then that energy is going to pass from organism to organism, starting with producers. The word produce means to make, and the producers are the organisms and ecosystems that make the food. That's going to be our plants, like this grass. Plants get energy from the sun by a process called photosynthesis. In photosynthesis, the plants are able to capture the energy from the sun and convert it to food. The plants make sugars that give them energy. I want to write the word photosynthesis here because the word photo means light, and the word synthesis is also another word that means make. So the producers are making their food from light energy. So the energy has now passed from the sun to the producer. Now, notice that I drew the arrow pointing away from the sun and toward the plant. Sometimes students think that food chains mean who eats who, and so they draw the arrows pointing the wrong way. The arrows are actually showing the flow of energy. So every time that you see an arrow, I want you to think gives energy to. So here we have the sun gives energy to the plants. Okay, the next part of our food chain is the consumer. Now, the word consumer means to eat or drink. So the consumers are going to be our food eaters, and for the most part, that's going to be animals. So let's add a mouse to our food chain. The mouse is going to be a consumer because it's going to eat the plant. So now we have the sun gives energy to the producer, the plant, and the producer gives its energy to the mouse. Now, there are actually three types of consumers: primary consumers, secondary consumers, and tertiary consumers. Primary means first, so primary consumers are going to be our first eaters. These are always going to be our plant eaters. So our mouse is going to be a primary consumer. Secondary consumers are second, which means that they are eating the plant eaters. For example, a snake's going to eat our mouse, so our mouse is going to give energy to the snake, and the snake is going to be our secondary consumer. Now the word tertiary means third. So the tertiary consumer is going to be our third eater along the food chain. The tertiary consumer is going to be the one that eats the meat eaters. So if a hawk eats our snake has now given the energy to the hawk. The hawk is going to be classified as our tertiary consumer. The hawk ate the meat-eating snake, which ate the plant-eating mouse, which ate the plant. Does that make sense? We can also classify consumers by what they eat. Herbivores eat only plants, so our mouse is an herbivore. Carnivores eat only meat. A lion would be a great example of a carnivore. An omnivore eats both plants and meat. A bear is an omnivore because bears eat berries and fish and other plants and meat. And of course, we're omnivores. Finally, some animals eat only dead things, and these animals are called scavengers. Vultures are an example of scavengers, and if you've ever seen them up in the air circling around and around, it's because they've spotted something on the ground that's dying, and they're waiting for it to be dead before they fly down and start eating it. So that would be a scavenger. Okay, so that takes care of our consumers, but we're not quite finished with our food chain. We need to add decomposers. Decomposers are organisms that actually break apart dead organisms. And this is important because when the decomposers break down the dead things, the dead organisms, it returns nutrients back to the soil that the plants need. So it's like nature's recycling. And mushrooms and bacteria are going to be examples of decomposers. So our food chain goes from the sun, and the sun gives energy to producers, and the producers give energy to the consumers, primary consumer, secondary consumer, tertiary consumers. And then any organism that dies that doesn't get eaten is going to give its energy to the decomposers that are going to break the dead things down and return nutrients to the soil that our producers need. I want you to pause the video now and copy this simple food chain into your notebook, and then describe how it shows energy flowing through the ecosystem, including how the arrows work. Press play when you're ready to continue. Okay, so food chains are a really simple representation of energy flow in an ecosystem. But in ecosystems, many times organisms can eat more than one thing, or they can get eaten by more than one thing. And the problem with a food chain is that it really only shows one possibility, and it doesn't really represent all of the different energy in the ecosystem. So we can trace all of the energy moving through an ecosystem by making a food web. A food web shows all of the possible food chains that exist in one ecosystem. It looks a little complicated, but really all you have to do is start at the beginning and then just follow the arrows until you've reached the end of a chain. So for example, let's start with this grass. Now this grass could give energy to the marmot, and the marmot would give energy to the red-tailed hawk. And that's one food chain. On the other hand, the grass could give energy to the butterfly, which could give energy to the grouse, which could give energy to that same red-tailed hawk, and that's another food chain. Or we could do the berries and flowers, could give energy to the deer, and the deer could give energy to the grizzly bear, and there's a third food chain. Let's take a look at another one. This one is showing the different types of organisms, and that's what I like. It shows our producers and our consumers and our decomposers at the top. So again, we could take this plant that could give energy to the rabbit, that could give energy to the coyote, which maybe dies and gets broken down by the decomposers, and there's a food chain. Or we have this other plant that could give energy to the cattle that gets eaten by the coyote, so it gives energy to the coyote, and again that coyote dies and gives its energy to the decomposers. So all of these different arrows from beginning to end represent one food chain in that ecosystem. Now, food webs are really important because they can show you how all of the organisms are related to other organisms in the ecosystem. And what this means is that if you have a problem in one part of the food web, it can cause problems somewhere else. And a food web is going to show you what happens if one part of the ecosystem gets out of balance. For example, let's look at this food web. We have a sparrow that kind of looks like it's in the middle of the food web. Now, if that sparrow, for some reason, if that population were to decline, if all of the sparrows got sick and disappeared, then that means that owl is going to be affected as well. The owl's not going to have enough food to eat, and so the owl population is probably going to decline. Let's take a look at another example. Let's say that we have too many shrews. There's been a population explosion, and now we have just bunches and bunches of shrews. Well, they eat grasshoppers, and so if there's too many shrews, they're going to eat all of the grasshoppers, and at some point there's not going to be enough grasshoppers left, which means that the shrews are going to end up starving, which means that the hawk is going to end up starving because it's not going to have enough shrews to eat. So anytime you get one part of the food web out of balance, it's going to affect other parts of the food web as well. Please pause the video now and copy this simple food web into your notes and then explain how it works. Then write a quick summary of what would happen if we had too many goats, or what would happen if we did not have enough rabbits. So food chains and food webs show how energy flows through an ecosystem, starting with the sun. There's also one other way that we can model energy flow through the ecosystem, and that's called an energy pyramid. Let's take a look at one. Here we have grass, our producers, at the bottom. And next, we have our primary consumers that eat the plants, which is going to be our grasshoppers. After that, we have our secondary consumers, which are going to eat the primary consumers, or the grasshoppers, and that's going to be these rats. And finally, we have a tertiary consumer, which eats the meat eaters, and that's the hawk. So basically, what we have here is a food chain, just represented in a different way. Why is it shaped like a pyramid? Well, one thing that an energy pyramid shows us is that as the energy moves through the food chain, a surprisingly large amount of it gets lost as it moves up a level. And that's what the energy pyramid is going to show us. The plants get energy from the sun, but they're using up a lot of that energy to keep themselves alive. So only a small part of that energy gets stored inside the plants. So when the grasshoppers eat the plants, one grasshopper needs to eat more than one plant in order to get the energy it needs. But then the grasshopper is going to be using up a lot of its energy to keep itself alive. So when the rat eats it, it's going to need to eat a bunch of grasshoppers to get enough energy. And the same with the hawk. The hawk's going to need to eat several rats to keep itself alive. Scientists think that as much as 90% of energy is lost every time we move up a level in an energy pyramid. That means it takes 10 times the amount of grass to feed one grasshopper. And then that means that it takes 10 times the amount of grasshoppers to feed one rat, and 10 times the amount of rats to feed one hawk. And if you think about it and do the math, we have 10 grass times 10 grasshoppers times 10 rats. That means that we would need 1,000 grass plants to end up feeding that hawk. So the pyramid shape, which has a lot of producers at the bottom and only one tertiary consumer at the top, is showing that the loss of energy. It shows that we're going to need a lot more producers to support fewer consumers. That one hawk is only going to get 1/1000th of the original energy that entered that ecosystem. In any ecosystem, it's going to take a lot of producers to support the consumers. In any ecosystem, you're going to have a whole bunch of producers, fewer primary consumers, even fewer secondary consumers, and only a very few tertiary consumers. If you've ever seen a nature documentary about the African savanna, you may have noticed that there are always large herds of zebras, but only a few lions or cheetahs. That's because of energy loss. Please pause the video now and copy this energy pyramid into your notes. Be sure to explain how the energy pyramid shows energy loss as you move up each level, and also explain why there are more producers at the bottom and only a single tertiary consumer at the top. Okay, that's it for today's lesson. You need to make sure that you understand how energy flows through an ecosystem, starting with the sun and moving from producers to consumers to decomposers. You should be able to draw a simple food chain, making sure that you draw the arrows in the correct position. You should be able to draw a food web to show how all of the different food chains are in an ecosystem. And you should understand how food pyramids show how energy is lost as we move from level to level through the food chain. If you have any questions, please ask. Good job. See you next time.